looking at note 6-1, square roots as inverses continued with composition. So use function composition to prove that f of x equals x squared plus 7, where x is greater than or equal to 0, so we're talking the right half of this graph, and g of x equals the positive version, not the reflected negative version, the square root of the quantity x minus 7, are inverse functions. So remember, with function composition, you have to find both f of g of x and g of f of x, and they both have to equal x in order to prove that the two functions are inverses. So let's start with f of g of x. Remember, this means that g of x is going inside f of x. So here's f of x. Where we see x, we're plugging in g of x. So x, the square root of x minus 7, is going in here for x. So then we're going to square it plus 7. So here we have, let's see, I'll keep using the same color. When you square a square root, remember that you don't get absolute value bars. So this is just going to be x minus 7 plus 7. And of course, the plus and minus 7 are going to cancel out, so you just get x. So remember, you don't have to write it all the way through, but you do have to show it as a last step. So f of g of x does equal x. So that's a good start. So now we need to do g of f of x. So remember, that means that f is going inside g. So this is g. Where we see x, we're plugging in f of x. So it'll be x squared plus 7 for x, and then minus 7. So then, of course, the plus and minus 7 will cross, so you've got square root of x squared. Now, this is where you do get the absolute value bars. And you would technically get plus or minus x here. But remember that this says x is greater than or equal to 0. So we're not going to choose the negative version. We're only keeping the positive version. So that means g of f of x equals x as well. So therefore, that's math terminology for therefore. Therefore, 3 little dots, f of x and g of x are inverses. Yay. Okay, so let's try another example. Use function composition to decide if f of x equals x squared minus 1, where x is greater than or equal to 0, and g of x equals square root of x plus 1 are inverse functions. So let's perform f of g of x first. So remember, that means g is inside f. So here's f. So I'm going to plug in g where I see x, so that'll be squared minus 1. So now remember, this squared up here is not going to cancel this whole thing because this square root is not over the entire thing. So what that means is you have 2 of these. It is very different. Let me just turn back over. That means there's 2 of these. This is very different from this problem because in this problem, the square root sign went over everything, so therefore you were able to essentially, I hate this word, but cancel those out because this went over the entire binomial here. But in this case, that's not the case, so this doesn't cancel that, and then you just square that. Oh, no, 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 no. That means there's 2 of these. So of course we'll FOIL, so square root of x times square root of x is essentially square root of x squared. Then square root of x times 1 is positive square root of x. And then the o and the I, this is the I, so that would be positive square root of x, and then positive 1 And then don't forget to drag down the -1. So of course those will cross out. And technically here you have absolute value of x plus these combined, 2 square root of x. Now of course you would have the plus or minus, but again, because we have this greater than or equal to, you would just keep the positive version. But nothing happens to this. This does not go away. So therefore, since f of g of x equals this hot mess, don't even have to do g of f of x, because f of g of x did not equal just x. So don't have to do g of f of x. So therefore, f of x and g of x are not inverses.